Hello, my name is Emma, and today I'm going to be talking to you about kinetic molecular theory. Kinetic molecular theory covers several principles in regards to how particles interact with one another. Today I will be going over these with you. The first part of this theory has to do with motion of particles and that they always move in a random pattern. If these were two particles in a gas, they would be moving in every direction, any direction, with the occasional collision. It is also important to note when talking about particles in a gas that we can visualize the particles as spherical objects such as these two. Why? This leads me into my next point. The reason we can use objects to show particles in a gas is because much of the volume of a gas is simply empty space. And when comparing the size of a particle to the space in between this particle and the next particle, the size of a particle is significantly smaller than the space between them. The third part to the kinetic molecular theory talks about how the only thing that determines the temperature of a gas is the speed of the molecules. The faster the molecules are moving and the more energy they have, the higher the temperature of the gas will be. The cooler the temperature of a gas is, the slower the molecules are moving. Part 4 to the kinetic molecular theory talks about attraction and energy between particles. There is no attraction between particles in a gas. Like I said, they are all random, so there's never any pull of certain particles to one another that they don't all have towards each other. Also, whenever collisions occur, whether it's with the edge of a container, a ceiling, one another, there's no transfer of energy between them. The final part to this theory is the movement of the particles and how they move in a straight line until colliding with another object. For example, if this is a particle and this is a container, this particle will move until a straight line until it bounces off of something else, causing it to go in a different direction, or bouncing off another particle and switching directions. But if there were no other particles or surfaces for it to bounce off of, the particle would go in a straight line. Thank you for listening, and I hope this helped clarify kinetic